Okay, Steve, I'm ready for your deluxe course on disc brakes. What's first on the list?
There are 3 different designs of disc brakes used in Chrysler Corporation cars for '67. They're all similar, so the same operating principles apply across the board.
Before you get started on brake operation, why don't you tell Ed and the rest of us why disc brakes are becoming more popular?
Oh, hi, Tech. Well, it's mostly because disc brakes are better suited to handle the punishment of extreme braking conditions. You see, repeated severe brake applications can make overheating and fading a serious problem with regular drum brakes.
I always thought drum brakes were pretty good stoppers, provided they were adjusted and in good condition.
True. Our Chrysler-engineered drum brakes are about neck and neck with disc brakes in performance under average driving conditions.
What do you mean by average conditions, Steve?
Normal starts and stops in city traffic, repeated expressway slowdowns, or a couple of fast stops from high speed, the kind of driving most of us think of as daily routine. But on the superhighways, where repeated hard stops or slowdowns from high speeds are more common, the fade-resistant feature of disc brakes is a distinct advantage. This is also true on hilly roads, especially with heavier cars and loaded station wagons.
I'm not sure I understand brake fade too well. I know the pedal feels hard, the brakes don't seem to do much stopping, and the pedal also goes down farther than usual. What makes the brakes act like that when they fade?
The villain is heat generated by braking friction. You see, where several hard brake applications come one after the other, brakes overheat and linings lose some of their friction efficiency. When this happens, there's less friction reaction between the drums and linings. This friction loss also reduces the self-energizing action of the brake shoes, so the pedal must be pushed down harder to brake the car. In addition, if the brake shoe friction loss is uneven, so is the self-energizing action. This means that right and left side braking can vary, and the car may swerve or pull to either side.
How about the added pedal movement?
That's another result of high temperature. Overheating expands the drums, and brake shoe pressure distorts them. The shoes then move out farther, so more pedal movement is needed to apply the brakes. However, with disc brakes, you can apply more braking force because the shoes push inward. The shoes squeeze the disc instead of pushing outward and causing distortion as in drum brakes. Here's what happens. As you can see from this assembly, the disc brake has a hub and disc assembly which turns with the wheel. It also has a stationary caliper assembly which bolts to the steering knuckle. The caliper carries the hydraulic pistons and brake shoes. The caliper straddles the disc so that a pair of pistons and a brake shoe on each side can push in on the disc with a clamping action when the pedal is pushed down. Now, as with drum brakes, hydraulic pressure is equal at all the pistons. So the pistons push both shoes inward against the disc with equal force on both sides. However, since piston force is equal on both sides, the disc cannot be forced out of shape by the shoes regardless of how high the pressure gets. And unlike brake drums, the heat generated by the friction expands the disc surfaces toward instead of away from the shoes.
Now, don't get the idea that fading happens only with drum brakes. Disc brakes can also fade if they're abused. Right, Steve?
Right, Tech. But you can repeat several very severe stops before this happens.
Steve, these brake linings are a lot smaller than those used in drum brakes. How can they do a good braking job with less friction area?
Disc brake linings are smaller than drum linings, but they're pushed against the sides of the disc with greater force. We get this higher force on the lining because caliper piston area is larger than that of wheel cylinder pistons. Besides this, disc brake linings are harder than drum linings, so they can resist compression by the higher piston force. These harder linings can also stand more heat, so there's less chance of fading. As a result, you get more consistent braking action and pedal feel in all kinds of stops.
You said that disc brake lining is more heat resistant than drum lining. So why don't they use it to reduce fading in drum brakes?
I'll answer that one, Ed. If you use the harder disc brake lining in drum brakes, you'd need a lot more push on the pedal. And to make it worse, you wouldn't get much self-energizing action to help you either. You see, one of the reasons why disc brakes use hard linings and high piston force is that they don't have self-energizing action. All of their braking action depends on direct brake shoe pressure against the sides of the disc.
That sounds like a lot of hard rubbing. What's the story on disc brake lining life?
Well, as with any brake system, abuse can cause rapid wear. But on the average, disc lining lasts longer than drum lining. After all, disc lining may be smaller, but it's about twice as thick as drum lining.
When you combine their small size with high application force, those linings must get pretty hot.
Right. Disc brake linings can get hotter than drum linings, but the air cooling vanes in the disc center section get rid of the heat fast enough to prevent overheating. Besides, the biggest part of the disc is always exposed to cooling air. As the disc passes through the caliper, it carries heat away from the linings, so there's little chance that heat will build up.
With all that disc exposure, why doesn't dirt and road splash affect brake operation?
Disc brakes are self-cleaning, Ed. The disc spins water and mud out of the brake, and the linings keep the disc clean. After you push the pedal a few times, friction heat quickly dries the lining and the disc surfaces. Actually, the high gripping forces on the discs give you good braking even when the brakes are flooded.
All right. Now tell me why our disc brakes don't have self-energizing action.
It's so we'll get uniform straight-line braking regardless of pedal effort or brake temperature. As I mentioned earlier, when drum brakes fade, one brake can energize more than the other and cause swerving.
That takes care of disc brake operation, Steve. How about the rear brake part of the system?
The rear drum brakes are next on the list, Tech.
I've been waiting to ask this one. If disc brakes are so good for the front, why do we use drums on the rear?
For 3 good reasons, Ed. Here's how they add up. First, by locating disc brakes at the front of the car, we put most of the braking power and fade resistance where traction is the greatest in a hard stop. You see, when you apply the brakes, car weight shifts forward in proportion to the braking force. This weight shift produces added traction at the front wheels and less traction at the rear, especially in a hard stop. Second, drum brakes at the rear provide a simple, mechanically operated parking brake system. The high forces needed to operate disc brakes make it extremely difficult to produce the same results with mechanical linkage. Third, there's no arguing the fact that disc brakes cost more than drum brakes. So when you have disc brakes up front doing most of the stopping, drum brakes give you all the braking you need at the rear.
Don't forget to tell Ed about the proportioning valve, Steve.
Well, I was saving that for last, Tech. The disc brake systems in our compact and intermediate size 67s have proportioning valves. The valve design is slightly different for each car group, but both valves do the same job of controlling hydraulic pressure to the rear brakes. You see, in easy stops with light brake pedal pressure, the forward weight shift is moderate. This means that car weight and traction are about evenly distributed, so we can use equal hydraulic pressure at both front and rear brakes to get straight, controlled stops. However, since more of the car weight shifts forward in moderately hard or severe stops, the balance between front and rear braking force must also shift forward, where the traction's greatest. But as you already know, hydraulic brake pressure has to be quite high to operate these disc brakes in hard stops. Now, if this high pressure is also applied to the rear brakes, it can lock up both rear brakes and the rear wheels will skid. So, on light pedal applications, the proportioning valve simply allows brake fluid to pass through as it flows from the master cylinder to the rear brakes. As long as brake system pressure does not go above 300 pounds, it remains equal at all 4 wheels. On hard brake applications, system pressure climbs higher and the proportioning valve goes into action. Above 300 pounds, the proportioning valve in the rear brake line cuts down any further increase in system pressure about 50%. In effect, the proportioning valve provides a pressure difference between the two braking systems to keep front and rear braking force in balance with the traction change caused by weight shift.
That takes care of everything but the larger models. Why don't they use a proportioning valve like the others?
The total area of the large front brake pistons in this brake system is so much greater than the smaller rear brake piston area that the same hydraulic pressure can be used front and rear. You'll find more information on the whole brake proportioning story in your reference book. But right now, it's time to stop the palaver and ask someone to flip the record so we can get on with our disc brake story. Now that we've covered the operation of disc brakes, why don't you give us some do's and don'ts on service and troubleshooting?
Okay, Tech. Since the step-by-step service procedures for disc brakes are covered in the service manuals, I won't repeat them here. However, there are some important things to keep in mind. For example, the brake shoes remain close to the disc when the brakes are released. With no pedal pressure, the linings either clear the disc a slight amount or stay lightly in contact. Now, as you know, pedal riding is bad with drum brakes, but it's absolutely out with disc brakes because only slight foot pressure will partially apply the brakes and cause linings to wear much faster than normal. And another thing, when you replace disc brake linings, be sure to check caliper pistons for free movement, especially where lining wear is quite uneven. If only one piston of a pair is doing all the work, the lining will show heavy wear at that end of the shoe. You can check piston movement easily when the linings are removed from the caliper and all pistons are free to move. Use your thumbs to push the pistons in part way, one at a time. If each piston moves smoothly with no jamming or roughness, it's okay. When you check piston movement, also check the caliper for fluid leaks and take a close look at the dust boots. If a dust boot is worn through, punctured, or torn, the piston will be exposed and can be damaged by water and dirt.
Now, don't get the idea that taper wear on linings always means piston trouble. Disc linings normally wear a little thinner at the rear because friction reaction to the rotating disc pulls the lining ends inward. Which brings up an important point. Where you remove the brake shoes for reasons other than lining replacement, be sure to put each shoe back in its original location. If the shoes are shuffled around, the wear patterns and grooves on the linings and discs will not match, and the brakes will not operate properly. Until the linings are reseated, the brakes will feel spongy and will pull to one side. So don't mix up the shoes and then expect the linings to wear in after a few pedal applications. Reseating may take quite a while with the hard linings used in disc brakes.
And speaking of brake pulling, the cause may not be in the brakes at all. If the brakes check out okay, but there's a pull to one side, check for loose steering linkage, poor wheel alignment, or a worn tire. Now, let's talk about disc assemblies. Besides severe wear or heat damage, there are two other conditions which call for replacement of the complete disc and hub assembly. One is excessive runout of the disc faces. The other is too much thickness variation. Now, in the first condition, too much wobble or disc runout forces the caliper pistons back into their bores and produces too much clearance between the disc and linings. When this happens, you'll need more pedal travel to take up the clearance, and there may be some vibration when you apply the brakes. Next, where disc thickness varies too much, the caliper pistons move in and out as the disc rotates, and you'll notice that the pedal pulsates up and down. This condition also causes brake chatter. Any questions, Ed?
I've got one on disc grooves, Steve. The other day on a lining replacement job, I saw you okay a disc that I thought was grooved bad enough to call for a replacement. How do you decide whether a disc is still usable?
Partly by the way the brakes work and partly by the disc condition. If the brakes operate smoothly and do not pull to the side before the linings are replaced, I figured the discs are still usable. Now, whatever you do, don't condemn a disc just because it has deep grooves. If you find discs that are grooved but smooth in a job where the brakes are otherwise okay, the replacement lining will seat in with no trouble after a few hard pedal applications.
Where the disc has rough grooves, they'll tear up new lining in a hurry. So a new disc is the answer. Don't try to refinish brake discs. Too much material must be removed to clean them up. Now, two final things on discs. When you inspect these brakes, make sure the air cooling passages in the discs are open so air can flow through. If the passages are plugged with mud, the disc can overheat and cause serious damage. On Valiant, Dart, or Barracuda disc brakes, the fluid transfer tube between the caliper piston sets should clear the disc by at least a half-inch. If you position the tube so it rubs against the disc, it can wear through. And now, Steve, this is a good time to tell us why it's important to use the correct material when replacing lining in these brakes.
Okay, Tech, it goes like this. The lining material for each type of disc brake is different. This means that replacement lining must have the same friction characteristics as the originals, or the braking action will be changed. In the rear, the story's the same because the original rear brake linings are designed to work in balance with the front linings. So it's best to use correct replacement linings, both front and rear, to turn out a good brake job. Any question on rear brakes, Ed?
I get the idea of brake balance all right, but what happens if the proportioning valve acts up?
Where the proportioning valve does not properly reduce pressure from the master cylinder in a hard stop, the rear brakes can lock the wheels prematurely. At the other extreme, a faulty valve can block off flow to the rear brakes, so there will be little or no rear braking action. If this happens, you'll have to use considerably more than normal pedal pressure to stop the car, possibly to the point where the front brakes lock up.
If you suspect that a proportioning valve is out of kilter, check it out and put in a new one if it's needed. Don't tinker or try to fix a faulty valve. You'll find more on proportioning valves in the reference book.
I understand you have to remove most of the fluid from the master cylinder rear reservoir before you install new disc brake shoes. What's the reason?
You remove the fluid to prevent a backup overflow when you compress the pistons. You see, the reservoir has enough capacity to keep the fluid from dropping below a safe level before the linings are worn out. But since the linings are quite thick, a large volume of fluid is drawn from the reservoir as the pistons move inward to compensate for lining wear. Only a half-inch of fluid may be left when the brakes are ready for lining replacement. Now, if some technician refills the reservoir before the brakes are relined, there will be too much fluid in the system. This excess will overflow from the reservoir if it's not removed before the new shoes are installed.
Be careful that you don't get dirt or moisture in the reservoir. And whatever you do, don't hit the pedal after you've pulled the fluid level down, or you'll draw air into the system. Now, why don't you give us a few words of wisdom on bleeding disc brakes, Steve?
Now that we have a tandem master cylinder, disc brake bleeding procedure is slightly different than before. We use a new method because it's more difficult to get air bubbles out of the dual brake system. First, remove the cover and gasket. Make sure the master cylinder is filled and keep the rear reservoir full while bleeding so you won't draw air into the system. It may be necessary to bleed out a considerable amount of fluid, so be sure to lead a bleed hose into a clean glass bottle or jar containing a small amount of brake fluid. Now, open the bleed screw at least one full turn and let the fluid drain without applying any pressure at all. The bleed screw must be fully open so small air bubbles will not be trapped in the caliper or pressure line. The bleed flow is normally slow without pressure, so don't expect a gush of fluid. Keep the end of the bleed hose under the surface of the fluid in the container and keep draining until the air bubbles stop.
The fluid will drain out without pressure because there's no residual pressure valve in the rear outlet port of the master cylinder used with disc brakes. Both outlet ports have brass tube seats, but only the front seat has a residual pressure valve behind it. Make sure you get rid of all the air, and don't be fooled by a solid pedal feel. If there's any trapped air in the system, the pedal may feel firm, but later may go nearly to the floor the first time it's used after the car has stood for a while.
Even though the pedal travel comes back to normal in the second and following applications, you'll probably have to bleed the brake system again. In the rear, you can bleed the drum brakes in the usual manner. However, don't worry if there's only a short spurt of fluid when you open the bleed screw. You see, the tandem master cylinder stroke is shorter, so it can't put out a long spurt like the previous cylinders. Finally, make sure the master cylinder compensating ports are open. To check the ports, get someone to pump the pedal quickly a few times and then hold it down to trap pressure in the brake system. You'll know the master cylinder compensation is okay if the fluid spurts or swirls as the pedal is slowly released. It's always a good idea to check the master cylinder compensating ports after you service a master cylinder or a brake power unit. If the ports are not open, the brakes may drag, and this can wear out disc brake linings in a hurry.
And that's my cue to bring this session to a close. You'll be seeing more and more cars with disc brakes from now on, so keep the things we've just covered in this meeting ready for action. Don't forget to read through your reference book, and use the service hints you'll find on its pages and the disc brake information in your service manuals. Keep your customers safe and happy with straight stopping brakes. See you next month.